Thanks, Peter. So now it's my turn to give you a brief introduction of Spanner and also the related background. Let's move on. So in the February of this year, Google launched a new solution or product called Cloud Spanner in its cloud platform. And in May, in the iOS 17, Google reintroduced the Cloud Spanner to the public, which means it's still brand new. Well, actually, Cloud Spanner is just an API, allow the end user to get access to the Spanner database itself. However, Spanner itself isn't new at all. It has been developed, implemented, and tested in Google for years. So, why it took so long before Google released Cloud Spanner to the public? Well, the explanation might be the Google experts are trying to make Spanner as powerful as possible to make all kinds of requirements, and that's why it takes so long. Okay, so what is Spanner? Or what is the most interesting and key feature of Spanner? So here's another screenshot from iOS 17 from Google, which listing some key features of Cloud Spanner, which is also actually the most important characteristics of Spanner itself. Okay, so let's see, we can see that Google Spanner is kind of globally distributed database with the scalability, and also it got the fully support and compatible with traditional relational semantics, including schemes, ACID transaction, and SQL. And also it is automatic. It got synchronous replication within and across regions for availability. So to sum up, Spanner is a globally distributed database with scalability, and also got support with traditional relational database, and also it holds autonomy and holds replication and holds high availability across regions. So in a word, Spanner is powerful. And the last one, just a bit of information from Google telling us that they have spent a lot of work in testing Spanner to make sure Spanner can be the choice. Okay, so before moving on to the specifications of Spanner, I would like to spend a few minutes to introduce a little information for the relationship between Maxstore, Bigtable, and Spanner, or the comparison of them. The reason why is that without Maxstore and Bigtable, Google might never reach Spanner. Okay, so Bigtable actually is not a database itself. It's just a data storage structure, which is designed to be highly scalable. But the bottleneck of Bigtable is that it hosts no query, so it means it's no SQL. So as a result, the Maxstore, which is built on Bigtable, holds some transaction functionality, but because it's no SQL, sometimes in some situations it can be quite limited, which means it's not powerful enough. I think it's also some of the reasons that make Google want to go to Spanner. So we can see that Google also adopted the concept of Bigtable, but only to maintain high scalability. And also, it adopted the concept of relational database, which makes Spanner a semi-relational, which also is NewSQL, which is a combination of the NoSQL and also the traditional relational database, which makes Spanner fully powerful. Okay, and another feature we want to dig in and show you more information later is the concurrency control mechanism of Spanner. It's because concurrency control is the most important feature in distributed system, as described by Peter at the beginning. So now it's time to go back to my teammates. We're going to introduce you the structure of Spanner, and then we're going to share our exploration of the concurrency control mechanisms, including the traditional locking models and also the timestamp-based true time API specified in Spanner. Thank you.